Welcome to Train Signal. You are watching Installing Cisco UCS Hardware. Now that you have an idea of all the components that make up UCS, how they connect, how they talk, and what their purpose is, it's time to start talking about how you actually install the gear. So in this lesson, we're going to start with starting the hardware installation, a little bit about what you need to do ahead of time, and then move into the physical space in the rack. So we'll talk about the size of the components, the total space needed, things like that. Power capacity and plug types, and power to the chassis. These are probably the two biggest hindrances on new installs. It's things that often get overlooked and things that can be a limitation depending on what your environment is. Next, physically installing the equipment, cabling the interconnects, chassis, and infrastructure, and finally, necessary configuration information before we move on and actually start powering up the gear. Starting the hardware installation. And the picture there on the right is one of our installs sitting on a kind of a scissor lift and the boxes for some of the basic components. Now when you get all your UCS gear, it looks complicated, but we saw in the last lesson that there's a lot less infrastructure here than there are in other blade enclosures. So don't let it get to you. Just separate things out and understand what goes where. Less things to plug in here than anything else, so it's very manageable. Highly suggest things like a scissor lift. I know it sounds dumb, but the chassis are very heavy. Even the interconnects are very deep, go way back in the rack, and weigh a lot. So you're going to need at least two people, preferably with a lift. So the first couple concerns are physical implementation tasks, confirming physical space in the rack, and the number one problem that we run into, making sure you have the right power cables and plugs to connect those into. First, physical space in the rack or racks. Rack space requirements are listed here. So we talked about the 6120 interconnect being 1U, the 6140 being 2U. The new 6248 UP is again 1U, and each chassis is 6U. So on the left, I've got basically a bare minimum configuration. Two 1U interconnects and a 6U chassis, 8U of rack space. You'll have two interconnects, so size those appropriately. And really, one of the issues that we run into a lot of times is limitation on power before we run out of physical capacity or physical space in the rack. So you'll probably, unless you're in a very dense data center, very high watt per square foot data center, you're not going to see a 42U rack with 7 chassis in it. Normally, you just can't get enough power into a rack like that. There are places you can do that, but most people that I deal with, even in large Fortune 500 companies, don't have that sort of watts per square foot ratio. One tip, if you're ordering racks for this gear, you may want to look at some of the deep rack offerings. They're a little bit deeper, give you more room for cabling, and just make it easier to work with. So like APC and others have racks built just for UCS that include things like the cabling and the PDUs and all of that right in the racks pre-delivered. So you'll say, hey, this is for for Cisco UCS, or maybe some supporting Cisco Nexus gear, and they'll already have racks designed and built for that with the right connections, with the right cabling. Some of them are already pre-cabled for some of the cabling offerings, so it can be very useful if you're doing a new deployment with new racks. So first of all, let's talk power capacity. Cisco has a power calculator for UCS. There's a link to it right there. It's good. I found it to be a little bit conservative. So sometimes when I give power numbers to customers, they're like, "Whoa, this is way too much," or "This is too much. We can't fit as much in a rack as we thought." No, a lot of times these are conservative numbers. Cisco has to be conservative. Every iteration of UCSM, the UCS Manager software, has gotten better and better on power allocation. So there's a lot of flexibility. You can even put power caps and power budgets on blades, but things like fan speed monitoring and things like that has gotten better. Powering down of components that aren't needed has gotten better. So it's gotten better and better and better over time. Just run the numbers and consider them a little bit conservative. Also, take a look at the numbers of different load. Are you really going to run all your blades at 100%? Are you really going to run them all at 50%, depending on the environment? So do some real world estimation. Look at the number of power outlets you need. So each interconnect, like you see in the picture there, has 2, so that's 4. Each chassis is going to have 4 large 2500 watt power supplies. So you want to make sure that the PDUs in your racks can support all that adequately without causing a problem. and you want to make sure and don't run too much power. You don't want to go, above say 80% or 85% on a PDU, because you risk running into, popping a breaker and causing another problem. So just things to keep in mind. Number of power cable types and options, there's a ton of them. So when you order your UCS gear, if you have not yet, or if you have, confirm it that you're getting the right power adapters and power plugs. That's really, honestly, it's the number one issue we run into in implementations. Someone won't check, or if they think they know what their power requirements are, and we turn out we need a non-locking plug when we have locking plug cables. Just little things like that will stop you in your tracks for 2 days while you wait on a cable. So just confirm that ahead of time. Power to the chassis. So this is often a concern, as chassis require a lot of power. Again, confirm your cable types when you order, but each chassis has up to 4 2500 watt power supplies. And so these can be configured one of two ways. We talked a little bit about this in the last lesson. N+1 or N+N or grid. N+1 is very simple. You run the power calculator, it's going to tell you how many power supplies you need. Let's say you need 2. Well, you'll probably connect 3. That way, if you fail one or fail a lead or a PDU, you'll be okay on the surviving members. Grid gives you even better survivability. So you may have power feeds from 2 UPSs or 2 distinct utilities. You can say, okay, 2 UPSs on the first feed, or 2 power supplies on the first feed, 2 power supplies on the second feed, and if anything fails, UCS knows just to kick it over to the other side. So it's very reliable, very robust. Take a look at your power. If you've only got feed from one UPS through one circuit breaker or breaker panel, then you're probably going to do N+1 redundancy. So now for the heavy lifting. Kind of a pun, kind of not. So once the power capacity and capability are confirmed, you're ready to start racking gear. Again, I'd use a lift. Chassis are heavy. You can strip all the stuff out of it, make it lighter. I have racked more than a couple of these, so it's suggested to get some help to do that. Use the included rack rail kits for installation. They're a little bit different, especially on the interconnects and what you may be used to, so take a few minutes and look and make sure they're correct. Run power cables and plug in as needed, and make sure everything is actually redundant. So it kind of goes without saying, but I'm going to say it anyway. We do data center assessments for customers, and it's often the case we run into things where they have 2 power supplies and devices that aren't actually run to redundant power feeds or even separate PDUs. Things happen in the heat of an installation or a migration, but now's the time to make sure you do this right. So split across PDUs, across feeds, across UPSs. Then, once your chassis is in a rack, you can install your fans, your power supplies, and your FECs in the back of the chassis. Some of these things, like blades, blades kind of vary by generation and types of memory. So I don't have a lot of information on, say, deploying blades, because when you get a new B250 M2 or M3 in the future, or different memory, you're going to want to look at the latest install guide on Cisco's site to say, okay, you're trying to put 192 gig of RAM in this blade. Here's how you need to do the banks of memory. Things like that vary greatly by blade, memory capacity, generation, so you need to look at that for the latest information. And now for cabling up the actual interconnects. And really, we're not so much talking about cabling to the existing infrastructure right now, though you can go ahead and do that, and then we'll do the configuration later. But really, we're talking about cabling up for management and clustering capability. So I've got some diagrams here along the right and down at the bottom. The top right, this cluster of diagrams here, this is a 6100 series. These are actually 6120s, obviously, because they're 1U. And down at the bottom are a 6200, a 6248. They do differ in how you cable these up. So the interconnects are the hub, excuse that pun, but they're the hub for cabling and communication. Server chassis cable into the interconnects, and the interconnects connect up to the core switch or core network, and also the storage fabrics if you use fiber channel. So there's a lot of cabling, but to start, we have to connect these together for management. If you remember, these are active and passive as a management cluster, but we still have to connect them together using 2 cables. So it's easiest to see in this diagram here and the diagram up at the top. You have L1 and L2. They're just link connections or whatever you want to call them, but the idea is you take a Cat5 or Cat6 cable and go from L1 to L1, L2 to L2. Do not cross the connections. Don't go L1 to L2 and vice versa. L1 to L1, L2 to L2. On the 6200 diagram I've got here is a little different, but if you look, ports 3 is L1, port 4 here is L2. So it's pretty much the same as it is there. L1, L2. Connect those as you see on the others. The difference is that on a 6100, depends if you call this the front or the back, but the side with the ports for connecting to the network and to the chassis is the same side where your management connections are. We can see it right here to the side. With a 6200, it's on the other side. So we have fans here denoted by number 2, power supplies denoted by number 3, and then a management block here to the left denoted by number 1. So they're on opposite sides. That's why I have two diagrams. Also, and this is kind of a mislabel. I've been looking for a different diagram from Cisco, but I don't have one that's labeled correctly. But each of the switches, both 6200 and 6100, have management 0 interfaces. If you're familiar with Cisco switches, management 0 is kind of the management interface, out of band interface as we really call it. You assign an IP to it, and that's the IP we assign during initial configuration here in a minute. What we're doing is we need to assign an IP. M1 is management 0. M2 is management 1. So it's a little bit labeled incorrect here, but the top one, and you'll look at the switch and it's labeled correctly on a physical switch, but it's the top one is management 0, and that's how we connect into the switch. You will do this for both switches, top and bottom. Each one will get an IP address, and that's how you can connect in. M2, management 1, really isn't used. And this big port you see right here next to the cluster of ports is your console interface. So if you're used to Cisco switches where you hook a blue console cable in and serial in into it for initial configuration, same thing here. We'll be doing that in a later lesson to kind of get them up off the ground. On the 6248, management 0 is top, denoted by number 5, and the console interface is number 6. 7 is a USB port that you can use for other things, not really used today, but it's a way to back up configurations. And also there is such a thing as a USB serial connection, so, or a USB console connection. So if you're like me and you're tired of carrying, USB to serial adapters around, there's some other options there. But keep in mind, L1 to L1, L2 to L2, IP address for management 0, that needs to be plugged into a management switch, on whatever network that you're assigning IPs. And initial configuration will be done through the console port here and the console port here. And now proper UCS chassis cabling. So again, kind of leaning on what we learned in the last lesson, you have two FEXs in the back of a chassis. A FEX goes to a interconnect. So, fabric extender FEX 1 will go to maybe the top interconnect. FEX 2 will go to the second interconnect. Normally, we do them just as you see in this picture. If you're used to fiber channels, you have fabric A and fabric B. We do the same thing with interconnects. We'll say the top one is A and the bottom one is B. Left FEX connects to top, right FEX connects to bottom. So for the 2104s, you can cable 1, 2, or 4 cables. You can't do 3. Remember, we talked about dividing 8 by 3. And for the 2208s, same rules apply, 1, 2, 4, or 8. Kind of dividing things by 8. Each FEX goes to its own interconnect. Do not cross connect. I still see people do that on initial implementations and wonder why they have problems. I know it's kind of a, I'm a networking guy, and that's our thing, is we want to cross connect everything. For redundancy, you do not do that here. Separate fabrics. Also, if you're using the combo module in a 6100, say the 4 gig Ethernet, 4 gig fiber channel module, do not connect chassis into those ports. Those Ethernet ports are for core network connectivity only. So do not connect those to a combo module. Here's some improper cabling. So first of all, let's see, what are we doing here? This guy is connecting 2 ports to the top interconnect and 1 port to the bottom interconnect. That's wrong. You can't do that. What else is wrong? Well, it's got a total of 3 ports. We can do 1, 2, or 4. Can't do 3. So right here in this one example, we have made 2 very big mistakes. It's going to cause us a lot of problems, and you're going to wonder why things aren't coming up and your chassis aren't detected and discovered. It's common to cross-connect switches. You do not cross-connect FEXs to different interconnects. I think I've said that about 6 times, so hopefully now we've got that. Now let's talk about supported cable types. So due to reliance on 10 gig Ethernet, there are some restrictions on which cables you can use. If you haven't done 10 gig Ethernet, you can't just plug in, Cat5 cabling. There is a Cat6 spec, but it's very, very new and kind of immature. For now, we have to use really one of two options. It's either copper, known as twin-ax, or fiber. And I say there that it can be used between the interconnect and the chassis and depends on the specs. It depends on the specs and it depends on the version of UCSM. Most things here, or really everything here, works with UCSM 2. Previous to 2, 1.3 and 1.4, the fabric extender transceiver, the FET, was not really supported. So let's kind of walk through these options. First of all is twin-ax. That's what you see in the picture to the right. It is really nice because you have the SFPs, the little modules on each end of the cable, and the cables all built together, pre-tested. So when you get it, it looks just like that as one piece. You can't pull the cable out of the SFP. So you're not plugging the SFP into a switch and the cable in the SFP and hoping all the connections are good. What you see is what you get. It's cheap. So for like a 3-meter twin-ax cable, you're probably looking at $120. That includes both SFPs and the cable. Very cheap. It can do 1 meter, 3 meter, and 5 meter. 7 and 10 are new supported options. I believe that's in UCSM 2. Those are what's known as active twin-ax. Not everything supports those, so you'll need to check compatibility list depending on what you're connecting. But it does give you the option of 7 and 10 meters where we used to be limited to 5. So again, cheap, easy, pre-tested, pre-built cables and modules. Next is FET, Fabric Extender Transceiver. This was a new offering by Cisco to kind of come up with a cheaper, low-power fiber optic module. And so this originally was built as part as the Nexus 2000 line to connect those to, say, Nexus 5000s. They're great because they're very inexpensive. Not as cheap as twin-ax, but pretty close. Now, with new versions of UCSM, they are supported. So if you want to go further than 10 meters, or you just want to use a cable that's not as thick, and cumbersome as twin-ax, you can do FET, and for a reasonable amount of money. Before FET, the only other optical options were SFPs for what's known as 10G base SR and 10G base LR. So multi-mode fiber, single mode fiber, short range, long range. These were exceedingly expensive. So normally we didn't see these used. We really don't have people that put chassis, 50 meters away from the interconnects. But for supported option list, here you are. The downside is that like a fiber SR transceiver can be $700 or more per end. So you put one end in the FEX, one end in the interconnect, you're at $1,400 plus price of fiber. So that's just something to keep in mind. A lot of these cables can be used between the interconnect and your core network. We connect the interconnects to, say, Nexus 10 gig switches using twin-ax when we can, and SR and LR modules when we have to. And that's where things can get kind of expensive. But again, twin-ax if you can, fiber if you have to. So cabling to existing infrastructure, I kind of hit on that a second ago, didn't I? But cabling to existing infrastructure is pretty easy. So the interconnects run down to the chassis using the cabling to the FEXs we just talked about, and then up to both the network, and if you use fiber channel, to the fiber channel switches. So if you use fiber channel, you'll install the appropriate SFPs in the appropriate ports. For the 6100s, you're going to have that expansion module, and hopefully, if you're using fiber channel, you ordered a fiber channel expansion module or the combo, so you'll take your 4 gig or 8 gig SFP, slide it in there, and then connect a piece of cable from that up to an existing fiber channel switch with an appropriate SFP there. The 6200s are easier. They're the universal or unified ports, right? So you can put a fiber channel SFP in any port and connect it to a fiber channel switch. For network configurations, you can do copper twin-ax that we just talked about, or the fiber SFPs. So for that, you may put in a 10 gig SR fiber optic module in your Cisco switch or someone else's switch, and an appropriate matching, got to be matching, 10 gig SR SFP into the interconnect. Again, if your interconnects are next door to your switches and you can use twin-ax, it's far cheaper. You don't want to pay $700-800 per end for fiber SFPs unless you need them. So a quick review of cabling. I know you saw this a couple of times in the last lesson, but again, when you're cabling up to the interconnects, you can do different mixing and matching of connectivity. So with the 4-port, it's 1, 2, or 4. With the 8-port, it's 1, 2, 4, 8. But you don't have to match across all chassis. You want to make sure each FEX in a chassis is the same. So if I put 2 on the left one, I want to put 2 on the right one. But if I have 3 chassis, I can do 1 and 1, 2 and 2, 4 and 4. It doesn't matter. So you may have high bandwidth or low bandwidth, high I/O, low I/O chassis, depending on how your environment is set. Just make sure that the 2 FEXs in a chassis are the same, and you stick to the supported cabling requirements and numbers. Finally, site planning. So after everything is kind of racked and cabled and powered, we need to get things ready for starting our basic configuration, which is the next lesson. So we want to go ahead and gather this information so we're not standing around looking at each other in front of a console, pulling up an Excel spreadsheet trying to grab a couple of available IP addresses. So the couple things you'll need. First of all is system name for the interconnects. You want to pick a name that means something. Maybe the UCS cluster, maybe the location, whatever. But what's going to happen is it's going to append a -A and a -B to them. The first interconnect is going to be -A, so we normally do the top one. Second one will be -B, we normally do the bottom one second. So if you say UCS-vSphere cluster enter, it's going to say UCS-vSphere cluster -A. And then for the other one, it's going to do the same thing, -B, and your overall cluster name is going to be the stuff without the -A or B. So pick a name. You're never really going to see it outside of UCS, but there you are. Password. It is not technically required to be 8 characters and complex. You can say no when it asks you if you want it to be complex. That's probably what I'll do in my lab, but things you do in a lab aren't things you do in production, so you want it to be 8 characters and complex. The default admin account is admin, much like other Cisco switches and products. You're going to need 3 static IP addresses. Interconnect A gets one, Interconnect B gets one, and then they get that shared cluster IP that they have between them. So those need to be on the same network, usually sequential, but doesn't have to be, but it makes a lot of sense, so go ahead and get those. They do have to be on the same network because they're going to have the same subnet mask, the same default gateway. You don't get to pick one of those for each of them. Then DNS server. That's optional, but it usually makes a lot of sense for things like logging and doing backups and other stuff. And finally, a domain name for the system. So give it a name, preferably based on the cluster name that you already gave it. Once you have all that together, you'll be ready to start powering up the interconnects and doing the basic configuration. And now we're going to jump over to the lab. And unlike a lot of labs in this course, really all the other labs in this course, we're not just going to show you an interface or jump on some equipment, something like that. When we're designing this course and putting it together, we wanted to kind of bridge as many gaps as we could between video and standing in a room doing instruction. And I've been to other UCS classes before, even by Cisco, and the manufacturer, and never actually seen gear in a classroom. So we do a lot of things remotely. We see diagrams and pictures like we have in this lesson, but we didn't really get a good feel for the equipment. And I wanted to do a little better job than that. So what we're going to do is we're going to do some video out of one of my labs. This is my Greensboro lab, and I'm going to show you the UCS gear that we have there. And we're not just going to point everything out in a rack. I'm going to show you how to install all the subcomponents, so things like power supplies, the different FEXs, blades, a mezzanine adapter on the blade, anything that I can. And I'm also show you how to connect all the cabling for these pieces and parts. So between the FEXs and the interconnects, power cables, and the management and L1 and L2 connections on the front of the fabrics. So it should give you a good idea of how to put these things together. And when I had the opportunity to do this, I also got as many other kind of examples as I could. So I have a couple of 2104 XP FEXs, the 2208 FEX, show you the different SFP options and twin-ax and fiber cabling, as many things as I could so that you'd understand what I'm talking about and see that and really get a feel. So if you've never seen a twin-ax cable with the SFPs already built onto the ends, I wanted to show you that so you would be very familiar with them if you were going out and doing your own deployment of UCS within your company. So I want to make that as comfortable as I possibly can. So with that, let's go ahead, we'll jump on over and I'll show you around the lab. So here we are in the lab. This is the Greensboro lab, if you remember that from early on when I went over a couple of my labs that I'm using. But what I wanted to show you is the components and the pieces, parts, the cabling, some of the modules that we use. I've got some spares right here to show you some of the options and give you an idea of when you get your equipment, how you put these together. So real quickly, let's go over the major components. We'll start at the top. Right here is our 2 fabric interconnects. These are the 2nd generation 6248 UP interconnects from Cisco. I can tell these are the 6248s a couple of ways. One is just by the the fact that they have 32 ports here. We've got the single modules here on the right side. That lets us take these up to a total of 48. And if you remember, these are universal or unified ports, meaning we can do anything we want to with these, whether it's 1 gig Ethernet,
10 gig Ethernet, 4 gig, 8 gig fiber channel. It all comes down to which modules we put in here and how we configure UCS Manager. So again, these are your two top of rack interconnects. Down below it is a 5108 chassis. So this is the standard, really the only chassis Cisco offers right now, with a single power supply. Even though it's got 4 plugs in the back, in a minute I'll show you the front, it's only got a single power supply, but we've got places here for our fan modules and our FEX or I/O modules. So I wanted to show you how you plug a lot of this equipment in. So when you get this, the first thing you're going to do is physically rack everything. Normally we rack these at the top of the rack up here somewhere, or maybe under switches, like I've got a fiber channel MDS switch here or a Cisco Catalyst Ethernet switch, but we normally put these at the top of the rack, and then we'll place the chassis throughout. So the first thing you're going to do is rack these, and then rack the big heavy chassis. Make sure you do that securely. And then you're going to have a lot of other parts to put in. So one of the first things you'll put in is a fan module. So I've got one right here. This is a normal fan module. Again, go back to the components. You'll remember I said we have 8 fan modules and 16 fans. We've got a fan in the back and then a redundant fan in the front that you can't really see behind the grill. These are hot swappable, just like all the modules in the chassis. So these are hot swappable. The FEX is hot swappable. So we take this very simply. It's got a button on the top and lock it right in. If you want to remove it, just press the button and pull it right out. So if you get a red light, you got a failure, fan status right here goes red, that means you want to replace it. Hot swappable, just put the new one in. So the next thing is normally your fabric extenders or your I/O modules. And so I've got both types here to show you. I've got the first gen 2104 and the second gen 2208. I've only got one of the 2208s, which is why I'm not using them in the lab. I want a pair. But this is the new, and you can tell because it's got 8 ports. It looks very much like the other one, but instead of 4 ports, it's got 8. But there are certain ways you have to cable this. 1, 2, 4, 8 connections. I've harped on that a lot in the lesson, but I want to make sure you understand. So this is the new 2208. This is the traditional 2104, the first generation. This is the one I'll go ahead and install. 4 ports instead of 8. Still, you can do 1, 2, or 4 connections to this. So the way you install these is to pull the little levers out like that. Line everything up. See if I can remember which way is up. There we go. If you're ever not sure which way is up on this, the text at the top that tells you the part number, you need to be able to read it. So that's a quick and dirty way to check. Let the levers engage, push them in, and tighten down the thumb screws. You don't need to go crazy on these, just enough to make sure somebody doesn't come by and pull that thing out on you. But that's that. You notice here there's a status light. We can't see it because we're powered down. We'll power up soon. And then you've got physical link connection lights on each of the 4 ports. So when you plug cables in, you'll know if they're live or not. But on the back of the chassis, that's really it. Fan modules and fabric extenders. Now, cabling. There's a lot of options for cabling these. The cheapest option is what I call the twin-ax copper option. So you've got the SFPs, one on each end. It's pre-made into the cable, so this does not come out. These are tested at the factory end to end as one complete unit, so you should be assured of a working cable when you get it. The beauty of these are they're cheap. This cable is about $150 for both ends and the cable. The downside is the length. These are passive. These are passive twin-ax, so they're good for 1, 3, or 5 meter. There is also a newer active twin-ax. Active twin-ax goes up to 10 meter, but that's still only about 30 feet. So between the interconnects and the chassis, that's fine. If you want to go interconnect to a switch that's far away, you're probably going to have to go fiber. So for that, you're going to need a fiber SFP. This is a fiber SFP and a fiber cable. This is a short range or a short haul fiber SFP. Why do we not want to use these? This is about $800. So you add 2 together, $1,600 plus copper plus fiber. So it becomes very cost advantageous to use twin-ax. But you can slot these in just like you would any other. And if you have 10 gig connectivity back to a core switch, we use the same connector, put it into the interconnect, and then run that back to our core switch somewhere else. So for distances above 10 meters, we need to use fiber SFPs. Just for your information, there's also two major forms of fiber connectors. LC, which are these little connectors. SC, which are your larger. If you see on the end, they're square. Most of your current generation SFPs use LC. For older connectors, and you can't see it, but to our older catalyst switch, we use these. They're larger. But when you're ordering SFPs or working with your reseller, make sure you get the right ones and make sure you get the right cables. The other type of connectors you can use, let's say you don't have 10 gig in your core network and you want to use 1 gig. This is a 1 gig copper SFP. It takes a standard Cat5 or Cat6 cable, and again, slots right in. Then you can run standard Cat5 or Cat6 1 gig. Of course, 1 gig is far less than 10 gig, but for a lot of environments, smaller environments, or where you don't have 10 gig yet, they work just fine. These are also very cheap, like under $100 kind of cheap. So they're not much at all, very useful. And finally, the last one, and I'll just steal one here, is for fiber channel connectivity. So fiber channel, being fiber channel, uses fiber channel or fiber optic cable. So this looks a whole lot like that 10 gig fiber module I showed you. So be careful. I see people in the lab pick these up all the time and misuse them because they think it's a fiber channel or they think it's a 10 gig SR. Just look at the top on the label. It'll have the part number and everything, and make sure you use the right one. But they are very similar, but you can't use one for the other. It's fiber channel only or 10 gig Ethernet only. But we just put that in just like we would any other. LC cable again, connects in and clicks in, and that's it. So when you do this, you'll rack these, rack this, put all your fans, your FEX modules in, and then you'll run your cabling. Twin-X cabling, usually from here up to the interconnect. And I had some Twin-X cable here a second ago. There it is. So we run 4 connections here for the lab. And so we would just plug these right back in. Do that for each chassis. Remember, this FEX goes to one interconnect. This FEX goes to the other interconnect. I do not cross-connect this FEX. Keep them all one to one, one to the other. Fabric A, fabric B. But connect those up, connect that. Run your cables, if you use fiber channel, to your fiber channel switch with the right optic, the right SFP, and then run it up to your core switch or your distribution layer switch, again using the right SFP. But that's it for cabling. Just the key for keeping costs contained on cabling is distance. If you can keep things in close proximity in racks, you're going to reduce your cost of cabling. If you have to go fiber for a lot of connections, you're going to start spending in the thousands and thousands of dollars just for SFPs and connections. So don't do that. So with that, we'll now move to the front of the chassis. I'll show you the power supplies, a blade, and the connections between the interconnects. So now I want to show you what one of the UCS blades looks like and look at the internals. So this is a B200 blade. This is an M1, so it's a little older blade, but an M2 still looks pretty much the same. So just going through the components. First, up front on the B200, we've got 2 small form factor hard drives. And so if we take a look, we can just pop these out. So you take this, that releases the lever, and out comes the hard drive. And then we just put it in and snap it back in. Again, given UCS, hard drives are very optional. Very few of our customers actually even run internal hard drives, but I have them here to show you. Then walking through the blade, the 2 gigantic copper things are the heat sinks for the CPUs. So these are Intel 5500, being the older gen. The currents are 5600, but dual CPU. Then we've got 12 memory slots. See here, we've got about half of them full. And one thing to keep in mind is when you deploy your blades, take a look at what the memory recommendations are from Cisco or work with your reseller. because it matters as far as which banks you populate, what type of DIMMs you use, because you want to maintain memory speed and capacity. So there are some guidelines around this, and there's really good install guides for each of the blade models that give you the supported configurations and the most high performance configurations. And then at the back we have our mezzanine adapter. So I believe this is one of the CNA adapters. This is not one of the Cisco VICs, like the M81, but they all look the same. And the way you install these are the two screws here, and you press down where it says press here to install. Below this is the connector that fits into the motherboard, and then you tighten these down. If this was a full width blade, it would basically be two of these, and you'd have two mezzanine adapters. You would do this twice. If you're only installing one mezzanine adapter in a full width blade, you want to look at the install guide for your blade and generation and make sure you choose the right slot. If it's supposed to be slot 0 and you put it in 1, it's not going to pick that mezzanine adapter up. So make sure that it's correct. So with that, we'll go ahead and slide a blade, and I'll show you how to install it into the chassis, and then we'll take a tour of the front end connectivity. So this is another B200. We're going to put it into the front of the chassis here. It's very simple, easy enough. This is with the cover back on. To take the cover off, you press this down and pull really hard on the top and jiggle it until it finally pops free. That's one of the more annoying things. But go ahead and slide it in. Oh, real quickly while I've got this out, these dividers here come out of the chassis for a full width install. So these come right out, and then you can put in a full width blade. We'll slide this in. On the front is a thumb screw and a lever. Wait till that makes contact, push in, and then gently tighten the screw down. On the front of the blade are a couple of things. This right here is for a dongle cable. So if you want KVM, direct physical KVM or USB, the blades come with this dongle cable. You plug in there, plug it into a monitor and a keyboard. And then we've got lights. We've got your alarm lights, your warning lights, network connectivity, the hardware reset button if you want to physically reset the blade, power, and there's a locator ID on the front here too that we can activate via UCSM and figure out which blade we're actually talking about. So that's how you install all of your blades. And so here's the power supply. We've only got one in this chassis. You can do up to 4. If you remember, I showed you the plugs in the back. There were already 4 there. They're ready to accept power supplies. So to do this, there's again another screw here. This lifts up, power supply comes right out. So the power supplies have the fans, everything self-contained. There's nothing else that you have to do. To install, you just slide this in, much like the blade. Wait till the lever locks. And then tighten in. Not being a thumb screw, we need something else for this guy, but lock that in. Do the rest of them depending on how many you need for your environment, and you're ready to go. So there's really nothing else on the front of a chassis to deal with. There's all the fans and all the connectivities in the back. At the top for your interconnects, we do have our cluster connectivity. So we connect 2 types of cables on the interconnects. One is management. You see here this says management 0. That is our connectivity to the outside world. It's what holds the IP address that we SSH your web into. All of our KVM access to our blades goes through these. Each one has a management 0. So we plug this out to the network. And then if you remember from our clustering discussion, there's also the L1 and L2 connections. So we need to cross connect those, and we want to make sure again and go L1 to L1, L2 to L2. And so we'll do that with a couple of short cables, and that's the next thing. And we want to do this before you power up your interconnects for that first initial install. So L1 to L1, L2 to L2. And the only other port on the front that you need to worry about is the console cable. So if you need, access for that initial installation where there's no configuration done, we'll plug this into a serial port on a notebook or a USB to serial adapter, and then use a terminal application like Terminal or Hyper-Terminal to log into this and do the initial boot configuration. Once that's done, we do everything else via the web interface. So with that, that is pretty much a complete cabling and physical installation of UCS. The only thing left is to plug in power to the back of the chassis and to the interconnects. I probably just told you that backwards. You really want to do the interconnects first, bring those up, and then plug your chassis in so it gets detected. But there's no power switches or anything to worry about. Just plug them in and you're ready to go, and that's it. The beauty of UCS is the cabling I showed you in the back is all the cabling you ever do. When I stamp out more chassis here, I don't run these up to my core and my net and my sand and all the other fabrics. I run them right up to these interconnects. So normally when we do deployments, day one we connect and configure these, and then from that point on, when a customer brings in a new chassis, it's a very quick connectivity to the interconnect and they're done. And that's really the beauty of UCS's physical connectivity. So with that, that's it for this lab.
So that's it for installing the hardware. That's the great thing about UCS is hardware is actually very simple. You plug everything up, you run some cables up to the interconnects, probably go ahead and run them to the core storage and core network, and really that's it and you're ready to start. You're not having to uplink every chassis. So let's talk a little bit about what we went over in this lesson. First, we started the hardware installation. We talked about, a lot of boxes come in, they all say Cisco. Start opening them up, putting things in piles, and get ready to put stuff in racks. Planning your physical space in the rack is important. It's not just important for will it fit now, but what about when I add 2 more chassis in a year? Where are they going to go and how are we going to connect to them? So that's other things to think about when you're talking about physical space in a rack. Power capacity and plug types. The number one issue on a new implementation. Check for capacity, check for plugs when you do your ordering. The time to figure out you're short on power is not when you're putting gear in a rack. It's to prepare for that so you're ready for it. Power to the chassis is usually, the biggest concern for most people. And as I said often, you're not going to be able to fill up a rack with a bunch of chassis because you're going to run out of power before you run out of physical space. Installing the equipment physically is real simple. Rack kits and screws and just heavy lifting, and it's just pretty normal stuff for anybody who's deployed servers or racked equipment. Then it's on to cabling the interconnects, the chassis, and the infrastructure. The things there are distance between the components kind of dictates the type of cabling you're going to use, which dictates the expense of that cabling due to 10 gig Ethernet. Kind of plan that out when you're looking at it. If you can get things close together, your cabling is cheaper by far. And finally, that site survey plan. IP addresses, cluster names, DNS, gateways, all that good stuff. Getting ready to actually deploy the new interconnects. And we'll be doing that right here in the next lesson. We'll actually be powering up gear and starting to do the configuration.